there are n people in a room, show that two of them have the same number of acquaintances. I think these should be people. So this is a problem on the Dirichlet principle. Yeah, I've heard some of people saying that, like pronouncing this as Dirichlet. But yeah, I like it as Dirichlet. Yeah, that's most of the world pronounce this as Dirichlet. So there are n people in a room, and there must be two who have the same number of acquaintances. So if you start with one, or like if you try proving the statement or analyzing the statement for small n, values of n, you can see some kind of pattern. So that's always the scenario, that's always the strategy to do. If you are solving some general case problem, do analysis for small numbers. So if you have two people in a room, let's say this is the room, and only two people, say A and B. So there are only two options. They either know each other or they don't know each other. So if they know each other, then both of them have one acquaintances. So like one each of them know one person. If they are not acquainted, then they have zero each, right? So that's the obvious case. Let's say the case where we have three people. And in this case, a person may know up to two people. So this one, so A either knows, like it knows nobody, doesn't know any of them, or knows only one of them, or two of them. For each of them is the same thing. So if you say A doesn't know anybody here, so zero, and then you are left with these two guys, right? If they don't know each other, it means like nobody knows nobody, so they all have zero acquaintances. So that proves the problem. But if they know someone, so they might know like each other only, so because they don't know A, so that makes like one and one here, right? So that's basically if you make it a graph, so there will be a graph with the same number of vertices, like same number of degree of a vertex. But the thing is, so when you do if you want to prove this, so like a more general case, say four people, a person may know 0, 1, 2, 3. So like someone A here, they may know nobody 0, and they may know like everybody 3. So like everybody means 3. And if you assume the opposite on contradiction, if you say that there is nobody, so like everybody has different number of acquaintances, what does it mean? So for different numbers, we have only 4 options. Everybody can know 0, 1, 2, 3. And then we have only 4 people. So that's the number of possibilities, and the number of people are same. So there must be some kind of one-to-one matching, which means let's say A knows 0, B knows 1, C knows 2, and then D knows 3. So that's the only way. So there should be this kind of distribution, but this distribution has a contradiction in itself, because here A knows nobody, D knows everybody. So which means A doesn't know D, but D knows A. But when two people know each other, it means that this is mutual. So if A knows B, then B knows A. So this kind of configuration is a contradiction. So it's not possible. So one of them, one of these numbers should repeat, because if you want to replace 3 or 0, if you want to replace 0 with some another number, that should be one of these numbers, say 1. Then it means you have these two repeating numbers. So generalizing this idea, if you have n people, for the number of acquaintances you have like n options up to n minus 1. But the thing is, since you cannot have a 0 and n minus 1 at the same time, nobody and everybody, you cannot have both of them at the same time. So you have n minus 1 possibilities. So you have to remove either 0, either n minus 1. And then distribute these n minus 1 numbers among n numbers. So that means there will be one repeating number, because n minus 1 is not enough to cover n. So there will be one repeating number. So that proves the idea that show that at least, so there are two people who have same number of acquaintances.